Hello, my name is Mike Hodnik, and I am going to create a track from scratch in 30 minutes using a code-based sequencer called TidalCycles, and also using my synthesizers. I've got a drum machine, an electron analog rhythm, and I also use a digital synthesizer called Harmor, which is hosted in my digital audio workstation, which is FL Studio. So I use TidalCycles to do all of my sequencing. TidalCycles is a live coding tool for sequencing, mainly used for sequencing samples, but I use it to sequence MIDI. So I can sequence my drum machine and the synthesizer. So I've got some drum sounds already programmed on my drum machine. Got a kick and a clap, hi-hat, some noise percussion, snare drum, and kind of a saw wave synth stab note there. So the drum sounds are all ready to go. And the Harmor synthesizer is not programmed yet. I just have a default sine wave. So we're going to get into the Harmor sound design second. First, I'm going to start with the code and to just get a sequence going with the drum machine. So in this demo, I'm going to kind of show the type of sequencing I like to do, which is kind of weird. It's unique. I like to try and create sequences that are kind of unusual, sequences you don't normally hear in other music. So I have a whole bunch of other helper functions that make things go a lot faster for me. And I need to change my mouse orientation here, my mouse wheel orientation. Sorry about that. So I have a whole bunch of helper functions that allow me to do things more quickly. Things like control MIDI control change values. I've got certain functions that map to different pads on the drum machine for different effects, or to be shortcuts so that I can know what pad number they are based on a MIDI channel. I've got other things to help with sequencing, shortcuts, and so on. So TidalCycles uses something called SuperDirt, which is a super collider quark. I'm not really going to get into SuperDirt very much, but I want to show that I have two MIDI devices configured in SuperDirt. I have my drum machine, my electron analog rhythm, which is on a SuperDirt synth called Rhythm. And then I have another MIDI device, which is my IAC driver on my MacBook. And that is being controlled on a SuperDirt synth called Harmor. So we can sequence those things from code. So I can very quickly just type rhythm, and my bass drum is on MIDI channel 1, 2, 3, but in Tidal it's 0 indexed. And I can play note C3, which should play the kick drum. There we go. The default MIDI velocity in Tidal is a little quieter than I like. So I have a helper function called limit, which will play it more loudly. All right, so there we go. So what I like to do is kind of have a call and response sort of pattern with the kick and the clap. So I am going to create a pattern of zeros and ones. The zeros are going to map to the kick drum and the ones are going to map to the clap. So I'm going to use a specific type of syntax here in Tidal that allows me to create a sequence that's based in a 16th note subdivision. So the cycle length or the measure length will be divided into 16 subdivisions, and then each 0 and 1 is going to last for a certain number of those steps. So I'll play a kick drum at for 5/16, kick drum for 3/16, a clap for 3/16, a kick for 9, a kick for 1, a kick for 1, and a clap for 11. And that sequence will just wrap. So there's obviously more than 16 steps in there. All right, so let's create a stack. A stack allows us to put more than one pattern together. So I have a helper function called rhythm, and then I have another helper function called pad3, which will play the kick drum. So there's our kick drum. We'll put our limit back. All right, so let's get a sequence that will play the kick drum on the zeros. So I have a helper function called map. M-A-P-P, which, so we want to, so pad3 is a nice helper function when I'm just going to play the kick drum by itself. But for this type of sequence, I want to play, I actually want to have a pattern of the MIDI channel. Kick is on channel 0, 1, 2, clap is on 3. So I'm going to create a mapping of 2 and then 3 of our pattern on note C3. So this should play the, what this does is it creates a mapping of the kick drums on 0 and the claps on 1. I'm mapping the 0 and the 1 to 2 and 3. There's our sequence. So this map function is doing a lot. Let me show you what it looks like here. So let me find it. Map. So this is a function that I just carry with me all the time. And what it does is I give it an argument of a mapping, an array of what I want the results to be, and then the pattern I'm going to input. And this fmap, this whole syntax here basically takes that original pattern of 1s and 0s and then maps it to what I want. I don't know if that was a good explanation, but but anyway, that fmap that's a Haskell function that will take kind of an array, and in this case, it will take the string pattern and map it to my MIDI channels. And then what I like to do is maybe create a way to modulate this. So I'll create a mod function and say every 2 reverse. And then I can put that in front of this. So every 2 cycles, it will play it backwards. Maybe kind of hard to tell because it's not really a regular sounding sequence. Okay, so next I'm going to add a little bit of interesting stuff going on with the sustain of the kick drum. So on my drum machine, I have what are called performance pads. So I haven't set it up yet, so let's set it up right now. I'm going to create a performance pad on pad 3 for MIDI channel 3, which is the kick drum. And then I have a function called perf3, which will allow me to set that modulation amount. So when you're using the drum machine, you can push on these pads and they're pressure sensitive to it's kind of like tweaking a knob. And in this case, pushing on the pad longer will increase the sustain of the kick drum. So perf3, and then I just give this a pattern. I'm going to have it randomly choose either all the way on or all the way off. So MIDI 0 or MIDI 127. And this performance is going to be a performance pad will be pushed once per cycle. If I do fast 3, it'll be pushed 3 times per cycle. Make it even faster. So now I got a nice boomy bass sound, kind of a subby 808 kind of thing. All right, let's add a hi-hat in there. So for the hi-hat, I like to use something called struct. So if you notice, I'm putting each pattern on its own line here. So I've got my kick and clap, the kick mod, and now I'm going to add a hi-hat pattern here. So if I do pad 11, which is my hi-hat, I can do fast 16. It'll just play it on every 16th. There's a function in Tidal called struct, which will allow you to define a pattern structure. So struct 1 times 16 is the same as fast 16. So 1 means to play the note, and 16 in this case means play it 16 times per cycle. You can do Euclidean sequencing in here. I can do 11 over 16. Or I can create a pattern. So every cycle, the number of Euclidean steps is to play is gonna change. But lately I've been doing something called, using a function called binary n, which allows you to specify a number of steps, and then it'll convert a number to binary, and it will make a pattern of ones and zeros. And the struct function plays the hi-hat on the ones, and it'll not play it on the zeros. So in this case, this integer results in a binary number, which is of 16 digits, which is what you're hearing. I can even change the number per cycle with the angle bracket syntax. And let's say sometimes or rarely I want the open hi-hat to fire. So we can do sometimes by 9%. So like 9% of the time, we'll play pad 12, which is the open hi-hat. We'll bump up the chance here. There we go. So now 12% of the time, we're any one of these hits being made by this struct sequence is going to be a hi-hat. Let's add a snare in there just for fun, which is pad 2. I'm going to shift it over by half a cycle to play it on the second half. All right, that's good for the drum sequence. So let's, what I want to do next is make a synth pattern that will go along with this. And we're going to sequence it in the same way. So let's make a synth patch quick. So here in Harmor, it's a very complex synthesizer, and I'm going to try and, I'm not going to be able to explain everything, but I'll just kind of describe what I do as I go. On the right-hand side is a display of all the harmonics that this synth is outputting. So the first thing I'm going to do is give this a unison voice. Maybe tune it down an octave. And let's, we're going to put a couple phaser filters on here. I'll reset these to... So I've, you can see on the right-hand side that the phaser filter is scooping out certain frequencies. I'm going to put an envelope on one of these filters. And I'm going to put another envelope on the other filter, have it go the other way. Adjust the width a little bit. I'm also going to add some compression and make it a little bit beefier, maybe add a little bit of distortion, just a little bit. Let's give it a pitch envelope. Actually not, no, we're not gonna do that. We might add the pitch envelope to the kick drum. We'll see. Let's make this a square wave. All right, so this is gonna be our kind of our main patch, but what I wanna do is I want to assign the first filter to modulation X, the second filter to modulation Y, and the pitch to modulation Z. So now I can control all these things from this XY controller right here. All right, so let's now get the sequence going here. So we'll put this on its own. We'll put this on D2. Limit. We'll do a stack, and this is going to be on Harmer. I don't know if I have a Harmer shortcut set up, so we're going to do S Harmer. And then we are going to do the same kind of mapping here. So I'm going to have this play on the zeros and not play on the claps. So we will do a we'll do a note map. We'll have it play note 0, which is middle C, and then we're going to have it rest on the clap like this, pat. And I think that's all we need for Harmer then. Okay, it's not quite together because I don't have the mod on the synth, so let's add the mod there. And our kick drum and Harmer are conflicting a little bit, so I'm going to add some EQ in Harmer so that it, whoops, we'll put a high pass filter on here to cut off those low frequencies. We could do some side chaining as well, but I'm just going to keep it simple here. And I think Harmer's a little quiet. Let's bring the volume back up. Okay. I'm going to turn the kick drum down a little bit. Okay, so now what I want to do is I want to control this XYZ controller from code. So what I'm going to do is I'm going to isolate a little example here. We'll do CCN. We're going to do MIDI control change 1. MIDI control change 1 is going to be for the X. Control change 2 will be for Y. Control change 3 will be for Z. So what I'm going to do is I'm going to start sending control change values to my DAW. And you can see this little blinking green light on the top left. That means that it's receiving control change values right now. So if I right click on X, while it's being sent, it'll automatically map it there. And if I change this to CCN2, now it's going to Y. I'll link to Y. And then control change 3 will go to Z. So now what I can do in my Harmer pattern is I can randomly modulate X. So every cycle, the X value is going to change. You can see it moving around a little bit there. So we can do the same for Y and Z. The trick with Tidal is that it will assign the same random values to everything in the same cycle. So I have to actually slow the random function down for each pattern in order to generate a different value. So now X, Y, and Z are all being randomized at different... Oh, they're all the same. That's not right. Why are they all the same? Slow 5. Did I do that wrong? There we go. No. What am I doing wrong? They're all... They're all moving the same. That's kind of weird. All right, well, we'll just do this. And the last thing I'm going to do is modulate the crossfader here. I can completely copy part A over to part B. We'll just do paste. And I'm going to make part B a little bit different. But we are going to assign the crossfader to Control Change 4. Make sure it's working here. It is, okay. And I am going to now move the crossfader based on our integer pattern up here too. So we'll do mod, and this will be ccv map 0127 pat. Oh, I know why, or cc. Okay, we'll fix that in a second. This is Control Change 4. I think my patterns, my control changes are all moving the same because I had my pattern backwards here. So I'm forcing it here to play to change the controls once per cycle, and then I'm slowing it down. Okay, so now we should be moving the crossfader here on line 22 according to the pattern we set up. Okay, so you can see that crossfader moving over to side B. And it's not playing because we're playing a rest over there. So let's change this to step up. And on part B, I'm going to engage the phaser, which is the magic ingredient of Harmor. And I'm going to dial in. If we move this crossfader over. We'll do, there we go. It's just bonkers sounds. Okay, so let's put, so now it should work. So now it should play the phaser side on the clap. All right, you know what? We are going to put a pitch envelope in here. So let's put a pitch envelope on the B side and the A side. We'll engage it for both. All right, so we're at about 25 minutes and I've got to record something. All right, so we're pretty good here. So now what I can do is I can improvise with the notes. I can improvise with when the synth hits. I can improvise with when the kick and the clap hit. I can reverse these. I can also flip the crossfader over to be the other way if I want. So let's record something here. I'm going to mute the hi-hat pattern, and I'm only going to choose the kick drum. All right. All right, so that's our start. All right, so we're going to hit record. Let's record something. Edison. Hopefully this will work on input. All right, here we go. We're going to record. Hey, it's recording my voice. Sweet. Okay, everybody stay quiet. Here we go. Let's move the panel out of the way here. Move panel to the right. There we go. More room. Okay, here we go. 3, 2, 1, go. I got to mute myself because it's picking up my mouse clicks. So let's stop and we'll do this again. And I'm going to mute the mic. All right. We'll see you in a couple minutes. All right, there you go. Hopefully we're at 30 minutes. All right, thanks for watching. Again, my name is Mike Hodnik, and this was a demo of how to make a track in 30 minutes with TidalCycles and a couple synthesizers. All right, thanks for watching.